Okay, so this next unit, we're going to be looking at distributions. So before we start in with probability distributions, we're going to look at just what were distributions in the statistics unit. How did we display those? So there were 5 main ways that we displayed them. We could display them as a table, in this case, the variable weight of the box. We could display them as a bar graph, like this elementary school student did, where they don't know the Roy Biv yet. Blue should be on the other side of the green, but that's okay. We can also create this into a computer version of the exact same data. We could create a histogram. The variable here is nightly rate, so the amount Airbnbs are charging per night. We could look at a Venn diagram. This is a distribution of the pets in particular houses. So the variable is the pets. And we could look at a pie chart. Okay, so this one is favorite fruit. My favorite fruit, for reference, pineapple, delicious. Okay, on the next one, what I want you to do actually is I want you to pause right here before I move on. I want you to think, if you had to split these into 2 different groups, what criteria would you use to split them, and which graphs or chart would go into which group? Okay, you can split them 1 and 4, you can split them 2 and 3, whatever way you can kind of think about it. So pause right now and do that. Okay, hopefully you actually paused. And we're going to look at 3 different ways you could have actually grouped those. So the first way is you could have grouped it 2 and 3 like this. And there's actually 2 different criteria that you could have used to group them like this. Okay? First criteria is looking at what type of variable is it. It's either a quantitative variable, like these ones on the left, so I'm measuring weight and I'm measuring amount of money, or it's a qualitative or categorical variable, where I'm looking at color or animal or fruit. Okay, so that's one particular way we can look at this. The other way we can look at this, same split, different criteria, is to actually think about, okay, well, what about that variable and the number that it's actually measuring? Well, on the left, we have continuous variables. The weight of the box is given as a range, and I can fit anywhere within that range, and just weight itself can go to any decimal places. The bottom, we have amount of money. Money can go to 2 decimal places at least, but again, we use ranges to do that, so we treat it as a continuous variable. The other side, we're counting things. Things, categories, are always discrete variables. I can't have like yellow 0.5, right? It's also, again, frequencies. I can't have 3.6 favorite fruits. That doesn't make any sense. Okay. The other way I could have split this up is like this, where I had just the Venn diagram by itself. How could just the Venn diagram by itself? What would that be? What would the criteria be to make that be all by itself? Hopefully you thought the Venn diagram is the only one there that has overlapping situations, right? Where I could have a cat and a dog in the same house. I couldn't have that in my house. My cat doesn't get along with other animals. She is a loner. But other households, they can have multiple pets. All the other things, there's no overlap. I can't have a box that is both a weight of 5 kilograms and a weight of 18 kilograms. That doesn't make any sense. I can't have an M&M that's 2 different colors. I can't pick 2 different fruits as my favorite fruits. Okay, so last unit we called those non-mutually exclusive events versus mutually exclusive events. Okay, looking forward in this unit, we are going to look at just mutually exclusive events. So you're going to be making tables to start all of these distributions. From a table, you're then either making a bar graph or a histogram. We're going to leave off pie charts. Pie charts and bar graphs technically kind of go together. We're going to make a bar graph when it's discrete. We're going to make a histogram when it's continuous. This and next week, we're only going to be looking at discrete variables. The week after that, we're going to do continuous variables. Okay, so just kind of keep that in mind as well moving forward. So now what are we doing moving forward though? Again, we're looking at distributions, but now we're doing probability distributions. All the graphs I gave you before in the tables, they were looking at frequency distributions, number of each one of the variables. Now we're going to be looking at probability of each one of the variable values. Okay, so it's the same thing. We're just not looking at frequency, we're looking at probability. So let's look at a very simple example to start. Let's look at creating a probability distribution for all the outcomes on a single dice roll. Okay, first, what's your variable? Your variable is the actual roll itself. What can occur on the roll? I can have the numbers 1 through 6. Then again, instead of frequency, I'm going to do probability. We're going to do one column for the fraction. Actually, I'm just going to show the fraction on this one. So it's 1 out of 6 to roll a 1. How many ways can I roll a 2? And 1 way out of 6. Rolling a 3, 1 out of 6. All those probabilities are 1 out of 6. Okay. I can take this chart then and I can display this a little more visually. I can make a bar graph again because it's a discrete. I can't roll 3.67. Doesn't make any sense. Okay. So if I were to make a bar graph of this, it would look like this. I'm going to display probability as percentage in this case. 1 divided by 6 is 16.6 repeated. So we get pretty close to 17 there. And they all end up being the exact same height. So that is a super exciting bar graph. Because they're all the same height and they all have the same probability, we call this a uniform probability distribution. So anytime you have probabilities that are all the exact same for every single value of your random variable. Now, I didn't talk about this, but that 1 popped up for a sum on the bottom. Some people take that for granted and they don't actually add their column up. It's really important that you do that to catch any errors that you may have made, right? If that doesn't add to 1, you know something's gone wrong because probability should always add to 1. Okay, let's take a look at another example where we do not have a uniform probability distribution. They are not all the exact same probability for each value. So a common example for this is a lottery. Selling 2,000 tickets. There's 1 grand prize, 5 other prizes, 10 other prizes, and 100 prizes, all worth different values. We're going to create a probability distribution for this model. Okay, so again, probability distribution, we're going to start with making our table. So we need to think about, okay, what's our variable? Our variable in this case, the thing that can change, the thing that we're most interested in, is the prize amount. So we're going to list all the different prize amounts. How much can you win? You can win 10 grand, you can win 1,000, you can win 250, or you can win 100. Okay, so that's going to be my first column. My second column is going to be the actual probability. How likely am I to get those prizes? I'm going to create 2 columns here for probability. I'm going to do one as a fraction, I'm going to do one as a percentage. Just because I think about things better as percentages in my head, but mathematically speaking, I can deal with the fractions a little bit easier. So, what's the likelihood of you're going to win the grand prize? Well, there's only 1 grand prize, and there's 2,000 tickets, so 1 out of 2,000. What's the probability you are going to win the second place prize? There's 5 of those, so 5 out of 2,000. Okay, and I'm just converting to a decimal by dividing. Nothing big going on there. Similarly, I can go through and I can calculate the other ones. And I always check my sum. Oh. What about my sum? Oh. Okay, neither of those are 1 or 100%. So something's going wrong here. What is going wrong? Okay. 1 grand prize, $10,000. I've got that. 5 prizes of $1,000. I've got that. 10 prizes of $250. I've got that. 100%. Okay, so I've got all the different prize amounts. What am I missing? What else could happen other than winning a prize? What usually happens when you buy a lottery ticket? You win big fat $0, right? What's the probability you win $0? How many tickets will win $0? Well, there's 2,000, and there's 110, 5, 1 number of tickets that are sold that win prizes. So what's left is 1,884 tickets. Okay? Probability of that is 94.2%. You have really likelihood of winning $0. So if I now change my sum, awesome, 1, 100. Great. Okay. I could draw a graph for this. Here's my pie chart, or sorry, here's my bar graph. A couple things that draw my attention to this graph, or that I am drawn attention to. For the grand prize, it doesn't even look like that exists. There's no bar. Even for the 1,000, the bar is tiny, right? Like I can see there's blue there. So I colorblind, I couldn't see that, that's for sure. So we got to manipulate this a little bit so we can make it a little bit more visible. You don't have to, but you could. Okay. So winning $0 isn't really considered winning a prize. So I'm going to actually take that one off. I'm going to look at it without that. So we can look at this. Now we can see a little bit more. It's still a pretty extreme difference, 5% versus 0.05%, but at least I can see them all on there, okay? The fact that these do not have all the same probability is something called non-uniform probability distributions. And there's 2 specific types of non-uniform probability distributions that we're going to cover in the next 2 lessons as well. This one's just kind of a generic, non-uniform, nothing else kind of going on here. It's just frequency over total to get your probabilities. Okay. What else can we do with this problem, though? There's a lot more going on here. Well, what are people considering when they're thinking about whether or not to buy a lottery ticket? A lot of people are thinking, okay, what's the likelihood I'm going to win a prize? Let's look at that. Okay, so I got my chart. There's the question. What's the probability that I'm going to win a prize if I buy just 1 ticket? Okay, let's apply what we learned last unit. Probability is always number of ways of meeting the condition you want. The condition I want is I want to win a prize. Over top of your sample space, the number of ways of doing anything. So in this case, that's the number of tickets. So the probability that my X is greater than 0, my prize amount is greater than 0, number of winning tickets over number of tickets. How many winning tickets are there? Well, there was 1 grand prize, 5 second place prize, and so on. We add all those up, and we end up getting 116 out of 2,000. I can reduce that. And then, so what does that actually mean? Again, my brain doesn't think fractions all that well. I think percentage is a little bit better. I get 6% chance of winning some money. All right, it's not very good. Only 6% chance. And that 6% chance can only get me like $100. Might not get me the big prize amount. We didn't consider the actual prize amounts at all. I feel like I should consider the prize amounts. I feel like that's important, right? Risk, reward. Is it worth it to buy a ticket? Okay, so how can I consider that? Well, I can look at what is the mean amount of money, 1 per ticket. This is kind of like doing a weighted average, a weighted mean that we did in stats. The formula for the weighted mean looked like this. Okay, you can pull that off your formula sheet, but it's just the sum of your weight times your X. So we made a whole new column, and we did that, divided by the sum of all your weights. Let's convert this now to something that's special for probability. So I'm just gonna write this bigger. Instead of calling this weighted mean, I'm gonna call it expected value. Expected value is, again, the mean amount or the mean value of your random variable. Mean value of your random variable, the average value of your random variable. I know I said that 3 times, it's important, okay? It's not how much I actually expect to get. It's the average. It's the mean. Okay, so let's continue on though. What is the weight? Well, the weight in this case is actually the probability. So I'm going to change the W's and I'm going to say that's my P of X. I'm going to do the same thing on the bottom. Now, the bottom there, it says sum of P of X. What's the sum of P of X? The sum of my probability. That's always just 1. So my denominator is 1, so I don't really need my denominator. So the formula for the expected value is the sum of my value times the probability of that value. Okay, so again, whenever I see a summation, I always think, let's create another column to get that done. So that's why there's another column, but we're going to start on a new slide to work on that. So again, we're going to start with our formula. We're going to create a new column, xp of x. So x times probability of x. I'm basically just multiplying sideways along this chart. 10,000 times 1 over 2,000. And I'm actually going to leave it as a fraction. It's going to be easier for me to sum if I have it as a fraction with all the same denominators, right? When you're adding fractions, you use common denominators. So I just go ahead and I multiply across. And then I add all of those up. I'm just adding up my numerators. Okay, so my expected value ends up being 27,500 over 2,000, which reduces to, or divides out to $13.75. Now notice I've got a unit in there, $13. Where did the unit come from? The unit comes from X is my prize amount. X was in dollars. So I was multiplying dollars times a probability, which is unitless. So dollars times no unit gives me dollars. So what does this mean again? No ticket is going to give you $13.75. There's no prize amount that's $13.75. So I'm not expecting to win that much. But that's on average. That's how much I'm going to get. If I were to buy up all the tickets, for example, I get $13.75 on average per ticket. Or if I studied all the individual people that bought tickets, which is probably a little more likely to have a lot of people buy one ticket than me buy them all, then on average, they'd win $13.75. It's this number that you want to look to be big. If that's a large number, then you're more likely to actually buy in and go ahead and get a lottery ticket. Okay? And there's my thing. So now what we're going to do is we are going to go to the spreadsheets. We're going to do this exact same question in the spreadsheet. We're going to also look at how we can manipulate a little bit, and we're going to look at a third question for this particular example as well. So moving on to the spreadsheets. Here we go. Okay, so here we are in the spreadsheets. I have all the information already typed in, and I organized it and color-coded it so it looks nice. Okay. What I want you to bring your attention to is this one right here. I have actually coded that in, rather than just putting in the number. That way, if we do manipulate things, that'll change automatically. So that's just the total, 2,000, minus each of the number of tickets that we've already dealt with for the prizes. Okay. Next, what I can do is the probability column here. So probability is going to equal to the number of tickets divided by the number of total tickets. Okay. Now I wanna lock in that total tickets because that is always gotta reference B1. I don't want it to drag down. I want the B3 to drag down to B4, B5, and so on, but that B1 I'm gonna lock into 1. So I'm gonna put my absolute reference or my dollar sign there. So now when I drag, I'm gonna go over here, again my cursor changes, and I'm going to drag this down, okay? Now I also wanna find the sum, just to make sure that that's going to be 1. So sum, fill all those up, and like so. I can also find the sum of this column at the same time. Drag sideways, that's 2,000, good, that's the number of tickets. And I know I'm gonna need the sum of my weighted category over here as well, so I'm gonna do that. Right now it's 0 because I don't have anything in here. So to answer the last question, we did x times p of x. So let's code that in. X is in column A. P of x is in column C. And then we're just gonna drag that down. Okay, so we end up getting the exact same thing that we calculated before. What's nice though is if I wanted to manipulate things and change it a little bit, say I wanted to change my grand prize. Say if I wanted to make my grand prize 100 grand. Well, now that brings up that mean winnings a lot more, right? Okay, so I can manipulate those things. Maybe I can just offer more tickets in certain amounts as well, right? And then we just press enter and it's all back to what I want. Now, the last question I want to ask about this is, what should the lottery company actually charge in terms of the amount of money? Well, a lottery ticket should definitely charge more than $13.75. If they don't charge more than $13.75, then they are going to lose money. If on average they're giving out $13.75 per ticket and they're only charging 10 bucks, then they're going to lose $3.75 for each ticket they sell. Okay, so we want at least that ticket to be more than that. So let's just go a little bit more than that. Let's just say we charge 15 bucks. It's not be greedy. How much money are we actually going to make? Okay, well, to figure that out, we need to first look at what's our revenue. Our revenue is going to be, well, $15 times the amount of tickets you've sold. $15 per ticket. That's our revenue. Okay, minus what's our expense? What did we spend? What did we give out in prizes? And there's a couple different ways you can do that. I think the quickest way is to look at, well, on average, I'm giving out $13.75 per ticket, multiplying that by the number of tickets. So I'm going to make 2,500 bucks. Is that enough? I don't know. Depends. That's a lot of work for 2.5 grand, right? If I'm a charity, I usually want to make a little bit more, especially being advertised as a charity. People are willing to spend a little bit more for these charitable type lotteries. So maybe I want to charge some more money. Let's just bump it up to 20 bucks. Notice I changed the cost per ticket, and automatically everything else that I need to change changes. Whoa, that just got me 10 more grand, right? That's a lot more money that I just made. And then you got to start thinking, again, risk reward from the business perspective, from the charity perspective. If I charge 100 bucks, I'm going to make way more money. But am I going to sell all my tickets? If I don't sell all 2,000 tickets, my revenue is not going to be quite as high, right? So you have to kind of think about that as well. What's the most money you think people are willing to spend? Okay, so maybe 25 bucks. There's a good amount of money you can win. So the key thing here is that you're kind of thinking about those things and you maybe discuss that in the discussion portion of a solution. But the biggest thing is that you charge more than that $13.75. Okay, now we're going to look at just what are the big ideas from this lesson. We've covered everything. What is kind of going on fully? So if we go here and play this slide, this is our summary slide. These are the big ideas. So probability distribution is either a table or graph showing probabilities for all the possible values. We looked at uniform probability distributions. They all have the exact same probability. We looked at non-uniform probability distributions. They don't have the same probability. Okay? We also then looked at expected value. It's the weighted mean for the particular variable with probability as the weight. We derived a formula for non-uniform where it's the sum of x times p of x. And the weight is our p of x. So it's actually the same formula. Okay. If I want to look at that for uniform, all the p of x's are the same. The p of x is just 1 over the number of random variables you have. Or sorry, the number of values for the random variable. So 1 over n. So if it's all 1 over n, if I'm multiplying x by 1 over n, x by 1 over n, x by 1 over n, I can factor out that 1 over n, right? And I can write the formula like this. Okay, That's it for today.